Hi everyone. Now we will discuss about another one transistor circuit. Here I am considering the two transistor, one with NPN and another one with PNP transistor. And here we are going to find out the voltage across the collector terminal of the transistor Q2. This we can call as VC2. In this current transistor, voltage across the base emitter of the Q1 will be VBE1 equal to emitter to base voltage across the transistor Q2, that is VEB2, which is equal to 0.728 volt. And we are considering current gain of the transistor Q1 will be beta 1, which is equal to 150. Current gain of the transistor Q2 will be beta 2, which is equal to 75. To point VC2, which is the collector voltage across the transistor Q2, we should know about the current across the collector terminal of the transistor Q2, that is IC2. Find the current across the collector terminal of the transistor Q2. We need to find the current across the base terminal of the transistor Q2, which is IB2. If we find the voltage across the base terminal of the transistor Q2, it is easy to find the current across the base terminal of the transistor Q2. So let us find the voltage across the VB2. And here we know that the voltage across the base to emitter terminal of the transistor Q1 will be VBE1, which is equal to 0.728 volt. That means VB1 minus VE1 is equal to 0.728 volt. And we know that here VB1 will be 2.5 volt, because here supply terminal is connected to the base terminal of the transistor Q1. So that V1 is equal to 2.5 volt minus 728 volt, which is equal to 1.772 volt. Here the emitter terminal of the both transistor, the Q1 and Q2, will connected to each other, so that V1 is equal to VE2, which is equal to 1.772 volt. And we know that the voltage across the emitter to base terminal of the transistor Q2 will be equal to 0.728 volt. That means VE2 minus VB2 is equal to 0.728 volt. So that VB2 is equal to 1.772 volt minus 0.728 volt, which is equal to 1.044 volt. So that voltage across the base terminal of the transistor Q2 will be 1.044 volt. So now we will find the current across the base terminal of the transistor Q2. That means the IB2 is equal to VB2 minus VB divided by RB, resistance across the base terminal of the transistor Q2. That is equal to 1.044 volt minus 1 volt divided by 20 kilo ohm, which is equal to 2.21 microamps. So that 2.21 microamps of current flowing through the base terminal of the transistor Q2. Now it is easy to find the current across the collector terminal of the transistor Q2. That is IC2 is equal to beta 2 times IB2, which is equal to, and we know that the current gain of the transistor Q2 will be 75, so that which is equal to 75 into 2.21 microamps. When we simplify this, we will get 0.166 milliamps. Therefore, the voltage across the collector terminal of the transistor Q2 VC2 is equal to IC2 into resistance across the collector terminal, it is RE2, which is equal to 0.16 milliamps into 1.5 kilo ohm. When we simplify this, we will get 0.249 volt. That means we are getting the 250 millivolt across the collector terminal of the transistor Q2. That is verifying the circuit. Voltage across the emitter terminal of the transistor Q1. That is equal to 1.772 volt. And similarly, voltage across the base terminal of the transistor Q2, that is equal to 1.044 volt. And that current across the base terminal of the transistor Q2 will be 2.21 microamps, and current across the collector terminal of the transistor Q2 will be 166 microamps, and voltage across the collector terminal will be 249 millivolt. So theoretical calculation and simulated value is approximately matching each other. So hope you are able to understand how to calculate the collector voltage in the PNP and NPN transistor cascaded each other. I request you to subscribe and like the video. Thank you. Thank you for the watching.